All right, let's dive in. Today, we're going to unpack what is, without a doubt, the most fundamental textbook in the entire field of artificial intelligence. Artificial Intelligence, A Modern Approach, by Stuart Russell and Peter Norvig. This book doesn't just teach AI, in many ways, it defines it.
At its very core, the book tackles one single massive question. How do you actually build something that's intelligent? So in this explainer, we're going to walk through the book's incredibly structured layer-by-layer answer. It's really a blueprint for creating intelligence right from scratch.
You should think of this book, most people just call it AIMA, not as just a collection of different topics, but as this single massive encyclopedia for all of AI. Its main goal is to give us one unifying framework that connects every single subfield, from search algorithms all the way to deep learning. And this is so important because it gives everyone a common language and a shared foundation to build on. And the key to that whole unified vision? It's the concept of the rational agent. This is the big idea, the central thesis of the entire book. It's the one intellectual thread that ties everything else together. It's the lens AIMA uses to look at all of artificial intelligence. So our little journey today is going to mirror the book's really elegant structure. We'll start with that core agent framework, and then we're just going to keep adding layers of capability. First, how to think in a perfect world, then how to deal with uncertainty, and finally, the really exciting part, how to learn from experience. Okay, so let's start at the very beginning with the foundation that the entire book is built on, the intelligent agent. Literally everything that comes after this is just about making this agent smarter and more capable. So, what is an agent? Well, it's pretty simple, really. It's just anything that can sense its world and then act on it. A self-driving car is a perfect example. Its sensors are the cameras and the LiDAR, and its actuators, the parts that actually do things, are the steering wheel, the brakes, the accelerator. This is the universal blueprint for any intelligent system. So the agent's whole life is just this simple repeating loop. Perceive, think, act. And get this, the entire 1,000-page textbook is basically dedicated to making that middle step, the think part, as incredibly sophisticated and intelligent as it can possibly be. Now, to get started, the book puts our brand new agent into what you might call a toy world, a world that's totally known, it's predictable, there are no surprises. You can think of it like a chessboard, and by simplifying things like this, we get to focus completely on the mechanics of pure thought. In this simple, clean world, the agent gets two main tools in its intellectual toolbox. First, it can search for a sequence of actions to get to a goal, kind of like how a GPS finds the best route. And second, it can use logic to reason about the world and figure out new things it didn't know before. The first tool, search, is all about seeing the world as a giant map of possibilities. The agent's job is just to find the best path through that map, from where it is now to where it wants to be, by exploring all the different options. But just blindly checking every single path, that's super inefficient. This is where a huge concept comes in, heuristics. An algorithm like A* doesn't just search randomly. It uses an intelligent guess, that's the heuristic, to estimate how close it is to the goal. This lets it check the most promising paths first and find solutions way faster. It's kind of like how you'd navigate a maze by always trying to walk in the general direction of the exit. The second tool, logic, gives our agent a really powerful language to describe the world. So instead of just seeing state A, it can now represent complex facts, like for any square on the board, if I feel a breeze, then a square next to me must have a pit. This is huge because it lets the agent make deductions and act on things it hasn't even seen directly. Okay, but that perfect, logical world, that's not the real world, is it? The real world is messy, it's unpredictable, and this is a massive turning point in the book, where our agent has to seriously level up its thinking to deal with reality. So this brings up a huge question. What does an agent do when its sensors aren't totally reliable, when its knowledge has gaps, and when its actions might just fail? In the real world, the black and white rules of pure logic just completely break down. So the book's solution is brilliant. We're going to replace certainty with probability. Our agent no longer deals in absolute truths. Instead, it deals in degrees of belief. It doesn't know for a fact there's a pit nearby. It believes there's a pit with, say, an 80% probability. This lets it actually measure and think about its own uncertainty. And the go-to tool for this kind of thinking is the Bayesian network. You can think of these networks as maps of cause and effect. They let an agent understand things like, okay, rain can cause wet grass, but a sprinkler can also cause wet grass.
And what's really cool is they let the agent reason backwards. If it sees the grass is wet, it can update its belief about whether it just rained.
Now that it's armed with probabilities, the agent can finally make truly rational decisions. It uses this principle of maximum expected utility, which is really just a fancy way of saying it weighs how good each outcome is against how likely it is to happen. It's all about choosing the action that gives it the best shot at achieving its goals.
So we've built an agent that can reason and act in a pretty messy world. But the final piece of the puzzle, and honestly the most powerful one, is giving it the ability to learn, to actually get better over time, all on its own. The book breaks down this huge field of machine learning into three main flavors. With supervised learning, the agent learns from examples where it's given the right answer. With unsupervised learning, it has to find patterns on its own. And with reinforcement learning, it learns from trial and error, basically guided by a system of rewards and punishments. And these learning mechanisms, they are the engines behind the most incredible achievements in modern AI. We're talking about systems that can see, that can understand language, and that can master games like chess and Go, all because they can adapt and improve from experience. So by the end of this whole journey, the book has put all the pieces together. We've literally built our agent up from a simple machine that just reacts to the sophisticated thing that can reason with logic, plan when things are uncertain, and most importantly, learn from the world around it. And when you look at the book's structure, you can see just how deliberate it is. It spends a lot of time building a solid foundation in reasoning and search, and then it puts the crown jewel on top, the powerful, modern tools of probability and machine learning. Every piece gets the attention it deserves. You know, the real takeaway here isn't just the collection of algorithms in the book. It's that coherent vision, that single map of the entire field, all centered around this really elegant and powerful idea of the rational agent. It gives us a blueprint for how to think about intelligence itself. And this brings us to the final and maybe the most profound question that the book leaves us with. As these agents we build get more and more powerful, how do we make sure that the goals we program into them are the goals we actually want them to pursue? This is the value alignment problem, and it's probably the single most important challenge facing the entire field of AI.